Hi, my name is Brittany, and I'm one of the educators here at EcoCycle. Today, I'm just going to give you guys a little background information on microplastics and compost, and specifically what people who run municipalities and compost facilities, what they can do to try to mitigate or reduce the effects of microplastics in compost and how many microplastics end up in our composting facilities. Because studies have shown that if plastic and microplastics end up in compost facilities, they don't stay there. So let's go ahead and get started. So this presentation is broken down into 5 parts. Part 1, what is a microplastic? Part 2, how do they end up in compost? Part 3, where do microplastics go? Part 4, how do they impact us as humans? And then part 5, next steps. So this is that action step, what we can do as municipalities that maybe write composting guidelines or compost facilities to ensure that this isn't an issue at our facilities. So to start off, what is a microplastic? Well, it sounds just like its name. It's a tiny piece of plastic, generally smaller than 5 millimeters long. That's it. Pretty simple, just a teeny tiny plastic. There are 2 forms of microplastics. So there are primary microplastics. The most common primary microplastic that people think of are microbeads from cosmetics. Think like a facial scrub with plastic beads in it, or nurdles from plastic production. So when things are going to be molded into plastic, the plastic is often shipped in little tiny beads called nurdles. And then there's secondary microplastics, which is the more common form of microplastics, which those are just formed through the breakdown of any larger plastic. This can happen in aquatic environments. It can happen in soil. It can be a solid microplastic fragment, like from a big plastic block. It can be a microfiber from synthetic clothing. A lot of cities and states have laws regulating microbeads from cosmetics, but those secondary microplastics are really tricky to deal with. And so we're going to talk about one way that secondary microplastics can be formed, and that's at compost facilities. So how do compost facilities end up with microplastics in them? So plastic-coated paper products are a huge contaminant. Some composting programs even will collect items like milk and juice cartons, drinking cups, paper plates, frozen food containers, takeout containers, ice cream cartons, basically any form of paper that has a plastic coating. So they'll end up at a compost facility along with our food scraps and paper towels and pizza boxes and all of the other things collected in the compost in stock. Now, why are these plastic-coated paper products an issue? So EcoCycle decided to do an investigation. We partnered with a facility called Wood End Lab, and that's in Maine, and they are an approved ASTM testing facility. So they're one of the facilities in the United States that tests if products are BPI certified. And they did the standard test to see what happens. So a standard ASTM D6400 test is a 180-day test to see how well things are going to break down in the compost. And the goal is to have total breakdown and decomposition. So we looked at a bunch of different materials. We looked at everything from cartons to paper cups to frozen food boxes, and then used just plain printer paper as a control. The advantage of using the variety of substances we did is they had different coatings, so everything from LDPE to PET to nylon, and these are also things that are commonly found in grocery store shelves. So here's what we found out. After 180 days, things didn't really biodegrade, especially the plastic coatings. They didn't biodegrade, and in fact, they slowed the biodegradation of the paper layer. So thinking things like a carton that is lined on plastic, paperboard plastic, that double plastic layer actually prevented the decomposition or the breakdown of that paperboard layer on the inside. When it's coated on both sides, not a whole lot happened. And then no matter what the product was and how little it broke down, microplastic fragments were shed and found in the surrounding compost. So if you take a look at these pictures, we have a food boat, a Stouffer's tray, a frozen food box tray, a couple cartons, and all of them show very little evidence of any degradation. So we know that when plastic-coated paper products end up at a compost facility, it's not going to break down into a smaller fragment, and those microplastics are going to end up in the compost. So why do microplastics in the compost cause a problem? So the goal of creating compost is to have farmers and gardeners apply it to the soil. We all know the great benefits of composting and applying compost as a soil amendment. It provides carbon and nitrogen and phosphorus and all sorts of great nutrients without having to apply any petrochemicals to our soil. But when our compost is contaminated with microplastics, studies as recent as 2018 have shown that compost does spread into the surrounding environment through runoffs. And the authors of this paper specifically have said that there's so much microplastic runoff from compost that it's actually a pretty significant issue of microplastic contamination into the environment, but it's one that is often unappreciated. So one that goes unconcerned, unregulated, but it's going to become an issue that we, as facilities that write guidelines or run composting facilities, really need to start getting on top of. So what do microplastics do in the environment? We know that they, especially once they get into the marine environment, microplastics have been really well studied in the marine space. Marine organisms will uptake or consume microplastics, particularly marine filter feeders. So think things like mussels, clams, and then this picture that I have here is a zooplankton called a copepod. Now those little green specks inside of the copepod are actually styrofoam balls. So we know that there's plastic in this copepod's GI tract. Now the reason that copepods are so important is they are at the basics of thousands of different marine food webs. So if you go all the way down to the bottom, you're probably going to find a copepod or a similar zooplankton right there at the base of that food chain. So we know microplastics are entering the food chain through these filter feeders. Now, why does it matter that a copepod eats some microplastics? Well, other things eat copepods. So we tend to eat larger fish species, and studies have shown that fishing hauls in Europe and California and Southeast Asia have all found plastic fibers and microplastics in fish and shellfish that is being sold for human consumption. Why? How does it get there? It gets there through a process called bioaccumulation. So think about that little copepod. Only going to eat a couple little pieces of plastic. But then something like an anchovy is going to come and eat a bunch of copepods. And then a squid is going to eat a bunch of anchovies. And then something like a tuna is going to eat a bunch of squid. Well, as it goes up the food chain, the concentration of plastics is going to get higher and higher each level up the food chain. And we as humans tend to eat species at the top of the food chain. Think things tuna, swordfish, salmon. Those tend to be the things that we enjoy eating, which are the things that are most likely to have the highest concentration of microplastics. Now, just on its own, sounds gross, right? We're eating microplastics. But in theory, they should just exit our body. But studies have shown that once microplastics enter our gut, they actually travel outside of our gut into the hemolymph, so our blood system, our lymph nodes. And this is especially an issue because microplastics can be an absorption site for something called persistent organic pollutants, or POPs for short. One of the most famous POPs is DDT. But the issue with POPs is they're what are called hydrophobic. So generally they have an end that doesn't like hanging out in water. And microplastics, because of their high surface area to volume ratio, act as a little vacuum for those POPs, which means that as we're eating microplastics, we can get more and more of those POPs inside of our bodies. So that is part of the reason why it's such a huge issue. Studies have found microplastics in human feces, in our guts, in women's breast milk, inside of some pregnant women's placentas. So we know that microplastics are part of our bodies, and we know that we don't want them there. So now that we know microplastics aren't great and how they get there from compost, what can we as compost facilities do? And the biggest thing is just changing guidelines to exclude plastic-coated paper products. And we've seen a lot of success over this happening in the United States. So there's about 330 composting programs in the US, and currently only about 10% take plastic-coated paper products. And if you go back about 10 years, that number was 50%. So as more people are becoming aware of the microplastics problem, it's becoming something that people are slowly changing their guidelines, which is pretty cool. Now in Canada, composting is much more common than it is in the United States. It's amazing that 6 out of 10 Canadian households have access to curbside composting. But currently, about half of Canadian composting programs take some form of plastic-coated paper product. So working on eliminating those contaminants in order to reduce the amount of microplastics that end up in the finished compost. And then the last thing that's something that we all deal with is contamination, right? People not taking the stickers off of their fruit, throwing the wrong thing in. So having robust outreach is always a great complement to guidelines. A well-educated public is generally going to be more compliant and have lower contamination levels than areas where education isn't as high. So I really hope that that gave you some encouragement and maybe some motivation to maybe re-examine guidelines in your area to see what can be done to reduce microplastics in compost. If you would like to reach out for more information, my email and our resident compost expert, Dan Mach, their email is here. There's also a link to our website. Our website has tons more information than this short presentation could have. It has our white paper related to our study and some more just basic information about how to reduce microplastic contamination in compost. So I look forward to seeing you all soon, and thank you.